Okay, so the, the this is the photo starter, service source, and then we enter the script and modify the first line. Yeah, it's design is unread, yeah, unread, and look, this is the STC file, and you can see that this file, this is edited STC file. This is the second, and what's the difference between the two files? Usually, if you synthesize the sample module, you use this file. If you want to synthesize for the whole chip, use the whole STC. Yeah. You can see that this file is very simple. In this file, you can see that I have three clocks. Yeah. So for this simple module, you use this file. Yeah. Okay. So and okay. And for the clock, you have to determine the clock length. Right. Yeah. Yeah, from the module, it's clock. Okay. Right. So modify the clock. Okay. And for this, you have to determine what's the frequency. This is the period for the clock, and the unit is nanoseconds. So it's 100 nanoseconds. So it's 10 megabytes. Yeah. And this is the node. You can enter any word. You can helpful to mark the synthesis condition. Yeah. Okay. I think we can attach maybe vector for this two items. You can skip it. And this is step. Okay. And this is default setting. Okay. Step. Okay. I think yeah. So we have finished this file, and you can see that at the end of this file, it launched the Genus tool. Yeah, Genus is the synthesis tool of the talent, and the source script is this file. So we go to this file. Yeah, and for better view, we the file type to still script. Yeah. And yeah, we have to check whether to modify the file. And then you can see that need a file list. Yeah, file list. Yeah. So because memory includes the memory. Yeah. And then for this two line, you don't need it. It's from the previous one, a very large project. Yeah, so it has another file list. Okay. I think we will remain the following lines default. Yeah. Okay. Okay. Synthesis and technology. Oh, for the technology, you can see yet. We have to determine uh, which memory, I mean, we can see it, it determines the technology node 15 nanometer. Yeah. But, uh, but in this set here, we don't have this file. We just have no, 28 nanometer. So you can copy, you can, yeah. This is the previous project. Right? Let's copy the file. So you can implementation services and the yeah, analysis. Oh, yes, yes, okay, okay. Oh, oh, it's so complex. Oh, okay, okay. Uh, maybe some more. Oh, okay. This is very simple. Copy, copy. Yes, yes, and this path is absolute. Okay. Um, oh, we have to reconstruct the folder status. Um, in fact, add a upper folder. Yeah. Okay. Okay. Let's go on. You can see launch the spinners tool. Yeah, spinners. And you can see automatically create the work folder. Work folder. And you can see the generated files. Yeah. It's a fixed structure. Yeah. And this work. And this is sensitive. And this is the name of the module. Yeah, yeah, yeah. And this is the test case. It's named started with the date, yeah, and the frequency, the period, yeah, and the risk setting. If you change the setting and run your different time, it will create different, yeah, another folder. Okay, and you can see, and this is the log. Yeah. Yeah. The log is very important, and you can see, oh, you can see that there is an area of error. You can see that invalid command name tail alpha. It means that this command is not supported in the current general group. So okay, this is a log. This is a log file. This is a terminal. You can down. Yeah. will have to fetch the start. Okay. Copy it and here. Okay. So this command is not support. Oh, I remember that the version in this server is older. Yeah, it's older. This command is the higher version. Yeah. So use this term. Yeah. Okay. 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 This is generic. For the phase of generic, we simplify the logic, and the map is replace the logic load with gate. Okay. Yeah. Okay. OPT is to optimize. Yeah. Optimize the timing. There will replace the large gate with a smaller. Yeah. To reduce the area. Okay. Okay. I'll try again. Okay. Now we can go back to the log and I can display the information. Okay. The noun and it executes the script. You can do the script. I mean this one. Yeah. It's okay. Go. Right. Yeah. Yeah. HTML design, and this is a constraint. And this is how many surveyor you can use. And the locating and SQL. Right. And this is technology neighbor. Yeah. Okay. So now we can get it. Yeah. Okay. And this information is very important. Right. The FTC. Yeah, FTC. What's the FTC? Design constraint. Okay. So you have to check to make sure that every constraint, is successful and low file. Yeah. Okay. And this is launch the design. Yeah, the design. And this shows that what the power constraint. Yeah. And this is explanation. Yeah. So that how the tool calculate the power and optimize the power. Yeah. I think this one is very important. You can say that you can set the weight. The weight means that do you mean that how to reduce the static power, or you want to reduce the dynamic power more? Yeah. If you increase this value, you can see that this is the weight. Yeah. If you increase this weight, you can say that the tool tends to reduce the static leakage power more. Yeah. And conversely, if you reduce value, the tool tends to optimize to reduce the dynamic power. Yeah. Okay. So I think it's successfully launched. Yeah. Currently it works well. And, yeah. Okay. It shows that the the stage or the optimization steps. Okay. Okay. The clock gating clock gating. Yeah, to reduce the dynamic power cost of the clock chip. And this is still the the hardware for if you use the flip-flop clock, and the 55,000. Yeah. Okay. Here, I think maybe this is the second step in terms of with the automate. First, okay, iteration. Yeah. First iteration. Second, yeah. You need to FTC requirement. Okay. And the currently the tested RAM rate of this model is very small. But just still need maybe 5 and after 5 minutes, you have to finish the phone services. Yeah. Mm. This information show that it split the task into 5 tasks and sent it to the different severe 1, severe 2. So accelerate the agency operation parallel. So for this, oh, yeah, looking at here. How much? It means that we in the first step, generate, yeah, and okay. You can see for this design and when stem. So the bit rate is 54 and multiplied by 1000. Yes. So in RTO design, we have to avoid using the large register. Yeah. For this you need the RAM to replace the large register file because it's a large overhead for area and for the synthesis tool. Yeah, because the data path, the number of data paths is this one apply the one. Yeah. If replace this with the RAM, the data path is only one. Yeah, yeah. Okay. Wait a minute. It generated the synthesis report, and I will introduce what is the report means. Yeah, it's very important. I think read the information from the report is the most important stage for the synthesis. What's that? Yeah. Usually the PDA, yeah. Power means that the frequency, frequency means that flag, okay, the kind of flag, it's large, but the frequency is very low. Yeah. Usually in ASIC design, the targeting frequency is 500 megahertz for our research. Yeah, but it's 1 gigahertz for the industry. Yeah. Okay. Uh, I think it will be finished soon. That's like that means that the timing margin, the margin is very large. Okay, and you can see that. Oh, okay. This is a log. Yeah, this is a FTP, and this is the output FTP. You can see that. This SSFTP is different from the input FTP, but the information is the same. Right. Yeah, because it is turned or unfold. Yeah, you can see. Right. For each bit. This FTP is very important for backend. Okay. Yeah, backend. The backend will fetch this FTP. Yeah. Okay. Okay. Currently in our team is responsible for backend. Yeah. Okay. And this is the report. But this report is the pre-synthesis, before synthesis. Yeah. I think the it can be used for to check the design. To check whether there is unresolved references. It means that the empty module, empty module, and the unloaded, and this is also important. Yeah, I mean that you don't need to wait to finish. You just launch the tool, and it will output this check back. Check, you can see. This check is for the design. Right. Yeah, design in that whether you have include all the module, or you have missed one, okay. The output, that is the design, and for this file, timing. Timing means that whether you determine the correct clock, and whether each register have been allocated a clock domain. Okay, is timing. Okay, and this file and this file I just copy this folder into here, because if we get a report, and we have to know what the source file. Yeah. So for each run case, we back up the source and the script. Yeah. And also another important thing that if you want to synthesis, you'd better to run on the viewer, not on the space called window. Yeah, because if you run on the Windows server, it runs on the remote server.
But someone
Yeah,
else
yeah,
can-
yeah. But here is on the code.
Local.
Yeah, if you shut down your computer, oh, yeah, yeah, yeah.
Okay.
Okay. Mm, I don't know why. Mm, you estimate the time, minutes, yeah, but uh, like, like, and you can see for your script, if you, okay, you want to add more files,
Mhm.
that is, yeah, yeah, okay, okay. Mm. If you fix the script, the only one you have to modify the this one. Yeah. If you have new design, then you add them into this.
Okay.
And the second one is to
Change the
yeah, yes, yes. You have to try.
design.
Here is the 10 megahertz.
Mhm.
Yeah, you have to try that to 100
Mhm.
and 500.
Yeah.
Yeah, and then to the which frequency the slack is 0.
Mhm.
Yeah.
Okay. Yeah.
And you have to this file. This file is for the power simulation.
Mhm.
But in the beginning of the project, we really don't need this file. Yeah. But when we fix the design file, we can use this file to run the power simulation.
Okay.
You can see that this script is very similar to this
Right.
script. Yeah,
Yeah.
you can see that. What's the design name, the clock name,
Mhm.
and the technology. But for this will idea is not the Murdoch, it's
Mhm.
the synthesis to Mechanic
Mhm.
and Mechanic. And the the basic principle or yeah is that you have to know what's the net list,
Mhm.
what's the technology file.
Mhm.
Okay, and what's the waveform?
Mhm.
Yeah, waveform mean uh, mean that up down up down up down.
Okay.
Yeah, okay. So this power simulation is very accurate. Yeah, right. Especially you use the VCD file. Yeah, VCD file will record the for each nanosecond the single is high or low, the whole progress. Yeah, so this power simulation is the most accurate. And
What is VCD?
VCD is the file format for simulation waveform.
Okay.
Yeah, it's one of the format.
Mhm.
And another format is TCF.
Okay.
TCF is how do you say? Tur Turbo Turbo Turbo. Uh, the difference between TCF and VCD is that VCD record the whole waveform, but TCF just record the switch activity.
Okay.
I mean that the such as the 50% high, 50%
Okay,
is low.
Low.
This is the switch activity.
Right.
It's only one value. One value is for TCF.
Right.
But for VCD, it records the whole.
Right.
Yeah.
Okay.
So VCD is very large. It's usually larger than 1 gigabyte. But for TCF, maybe 100 megabyte. Yeah. Okay.
Oh.
I think it's very small design. The progress is wow. And okay. Oh, we can. Oh, we can use the previous one.
Oh yeah.
Yeah. So another side.
Yeah.
Oh. Yeah. Oh. This is the 4.8. Yeah. Multiplication and optimization. You can see that this is the report. You can see this report is general, and this is for area power. This is for timing. Okay. You can see the most important file is this summary. Yeah. You can see that's a flag.
What's this like?
Yeah. That's a flag. And that's the area. Yeah. This is the fail area. But the net area is zero because we doesn't include the technology lab.
Okay.
Yeah, if lab means that it's a physical file. Physical file means that it has var width, var length. Yeah. And
zero because they didn't include.
Yeah.
Okay.
If you don't include the left error is zero. Because they don't know.
Yeah.
Okay. And after check the summary is correct, you can check the timing. Yeah. The timing. Yeah, for the IC design, timing is very important. Yeah. It's more important than the error. Yeah. So the time must be covered. Yeah. Okay. Okay. You can see this is a flag, and you can see this is the clock beginning point.
Yeah.
Beginning point. And yeah, this is the eternal delay, and this is the arriving time. Arriving time. Yeah. And this is an instance. It's an instance. Okay.
Individual cells.
Yeah. Okay. And this is the combined logic. And this is a register. It's a flip-flop. So this part is very simple. The first part is the input port. Yeah, you can see that here. Input port. And then is the adder tree and the sound. And this is the combined logic part. It's the second part. And this is the third part. It's the flip-flop and the output. Okay. You can see that this is the runtime, and this one this is rest or fall.
Okay.
Rest.
Or restful.
Yeah, it's the edge
Okay.
direction
Mhm.
of the clock.
Mhm.
Yeah, you can see that here is the red and four,
Mhm.
and you can see this is four, and this is the red. And
Mhm.
why this is four and this is that? You can see this cat is
Okay.
yeah. Okay, and you can see this is red, this is four.
Mhm.
The reason is that this is inverter.
Mhm. Okay.
Yeah,
Okay.
it's
Yeah.
inverter.
I.
Yeah, inverter.
Yeah.
So this is right in after inverter is four out. Okay. Okay.
Okay.
And this is arriving time.
Mhm.
Okay. And this is requirement.
Mhm. Okay.
Okay. Requirement. So okay.
Because
Use that. Yeah.
right.
Use this value to stop this value.
Mhm.
Okay. This is the margin.
Mhm.
The we can second four. You can say that this is this module. This is module, and this is the clock
Mhm.
beginning point.
Mhm.
And this here. That is
Mhm.
this has is the input delay.
Mhm.
The input delay is defined in specific.
Right.
Yeah, this is 250
Mhm.
nanosecond.
Mhm.
Yeah, and this delay you can say that this part is the combined logic,
Mhm.
and this is the sequential.
Right.
Okay, and you can see that this is the arrival time,
Mhm.
and this is uncertain. Uncertainty. Okay, okay, and you use this to oh no. So you use
Okay.
this one.
Yeah.
This one. Yeah. Okay. Oh, yeah. Okay. Um, mm, if you increase this value,
Mhm.
it means that your constraint is strict. Is structure.
Mhm.
Yeah, structure. Because you increase this and this one will be smaller.
Smaller.
Yeah.
Yeah.
Means that the timing is structured.
Yeah.
Yeah. Structure. Yeah. And also, if you increase the uncertainty,
Mhm.
the timing, the concept is also set.
Mhm.
Yeah. Okay. Oh, okay. Okay. Oh, Spanish. Okay. And go back to audio. Yeah. Yep. Why? Hmm? Why? What's wrong?嗯，最近的这种刚去的这个why there is no report? 嗯嗯 I think maybe this is a common problem or Euro problem. If you internal this problem, you show that you have Spanish synthesis,
Mhm.
but there is no
No.
file generated.
Mhm.
You can try to
Right.
manually
Mhm.
manually copy the and okay,
Right.
yeah, okay, but on the but, oh, okay, okay,
Okay.
you can say timing
Mhm.
and the gate. Okay, gate means that how many standard cell
Uh-huh.
is used. Yeah. Okay. For this
Mhm.
standard cell is used
That's fine.
24.
Uh-huh.
Yeah. The total area and which library.
Right. Mhm.
Yeah. Yes, time cell comes from. Okay. And this is a summary.
Uh-huh.
In that the ratio
Mhm.
from of different library.
Right. Yeah.
Okay. Okay. And this is okay.
That was
So that is a breakdown.
Mhm.
Potential inverter buffer. Yeah. Okay.
Okay.
And the power. We generated different steps, different levels of power.
Mhm.
This is the top. This is top.
Mhm.
This is more. This is detailed. Okay. This is more detailed. More detailed.
Okay.
You can see that the number of cells and the leakage and this is the dynamic. This is the total. Yeah. Okay. And this is the break power breakdown
Mhm.
for each instance. And this is the area. It's the same as the power.
Yeah, more
Okay.
details. Uh-huh.
And this is the path group.
Mhm.
And you usually it has three path group.
Mhm.
Input to
Right.
register.
Mhm.
Yeah. And register to out.
Mhm.
And this is the
Right.
yeah. And this path group is internal.
Mhm.
Register
Yeah.
to register.
Mhm.
Yeah. Okay. And this is the net list. Net list. You can see that usually the net list have the same structure
Mhm.
of the design, but it replaces the Verilog use the standard cell. You can say it's a standard
Okay.
cell. Yeah. Okay. And yeah. And I remember that the general have a tool you can import the net list and it show the schematic. Yeah. It's a GUI. Yeah. You can see that this is the instance and what's the input line, input where, yeah, input where. This is a file that you can use the schematic.
Mhm.
It shows the okay. And this file is SDF. It's a static delay file and okay. It's mark delay.
Mhm.
Yeah. I mean this is the first instance. This second instance. And that is the net. So it will mark each net delay. Yeah. And this whole folder is only for backend.
Mhm.
Yeah. So you have that. Okay. And this is the check the design,
Mhm.
and this is the check for timing.
Mhm.
You can see that this is post and
Okay.
it's pre
Yeah.
before is the post.
Mhm.
Usually the post file is more accurate,
Right.
but this file is so complex
Mhm.
because it is turned the delay.
Right.
That's all. That's all.
Okay.
Yeah, yeah. Yeah. If you want to have a new design that modifies the SEO
Right. Yeah.
and that
Okay.
increase the frequency,
Mm-hmm.
I think this is very, very simple.
Okay.
It's
Yeah.
very simple.
Yeah.
Okay.
And what is it?
Mhm.